Hi my friends, today we model this part with the name strong lever and having this drawing. We start by creating a contour with this dimension 110, diameter of 52, diameter of 32. You see here, here and here, but better here, that there are some taper faces of these features. This is the part 28 from my collection of 100 mechanical parts. New empty document. Take a look of this workbench and select CAD, not Blender, because we create mechanical parts. New sketch in the plane XY. We draw a polyline starting from somewhere here, going here, MMM 3 times, then we go here, then MMM once again to this point. Tangent are these two entities. Coincident are this center with this. This center with this point, and also coincident is this point with this axis. Now dimensions, 3 dimensions. This is 52 divided by 2. This is 32 divided by 2. And this point is placed at a distance of 110. Okay. Close. And we go to the drawing. You see here 4 millimeters thickness placed on this medium line. The distance between this and this is 12 plus half of 4 millimeters. Yes, you have to notice this 30 degrees. It is the angle between this and internal face. We apply pad or extrusion of 12 plus 4 divided by 2, and the angle is with minus 15. 15 is this. No, we don't want this. We want minus to be right as you can see here. Okay, now we want to create this shape. You see this dimensions, radius 10, radius 4, and the other circles 64.5 is this one, and 51 is the other. You also can see here the depth of that shape, 12. The problem is that we don't have this thickness. We have to calculate it by using this section We select this plane XY, then datum plane, then we place here the value 4 divided by 2. You see, now is in an upper position. This is the plane for a new sketch. We hide the datum plane. Yes. Now we project 1, 2, 3, 4 entities. We apply section view, and then we create 2 lines. 1, 2. We want to place here a distance. We start by creating parallel entities, and then we have to find this dimension. To do this, we use a polyline with a sloped line, then MMM. We go here, here, and back to the start. This is horizontal. Then we apply equal to these 2 sides. The radius 2 is this. The angle is 30. And this distance is 12 minus 2. Now we don't like to have this in any pre-position, because we want to know how many degrees of freedom we have here. This is why I select a point like this one, and I apply constraint block. I didn't select it very well. I select this and constraint block. Now it's okay. You see, we cannot move this, and it is green. Okay, we want to find this dimension. It is not a proper dimension because this was well defined. This is why we make this a reference. Okay, you see, now we have a value for this distance. Dimension here is 9.5, no matter about this decimal. Okay, this is also 9.5. Good. We place an arc with center. This is the center from this point to this point. Another one with this center from a point on a line, and another one. We trim the extensions and we apply dimensions. As you know, this is radius of 64.5 divided by 2, and this is 51 divided by 2. Now we apply fillet on these corners. This is one, this is another. They are equal, this with this, and the value is 10. The radius is 10. Here the same. Fillet, fillet equal the two, same radius. Then radius 4. We still have 1 degree of freedom. Let's see what is that. This distance I lost that distance. I place it once again. 9 plus 0.5. Now we have a fully constrained sketch. Close, and we know where is that sketch. Inside this volume at 2 millimeters up, we apply a pocket of that reversed, you see, through all reversed up. Okay, we can measure the distance between this and the bottom. Let's make this and this. The distance is 4 millimeters divided by 2. Yes, close. Now we want to apply a taper like here, but for a pocket we don't have any taper. You see here we don't have any taper. Then we have to create our own taper. Here it was a taper of 15 degrees, and we place here the same taper. We create a new sketch in the plane YZ. Then we apply view section to have access inside, and we see that here is an arc. Yes, so we have to find the ends of this small arc. We apply project of this arc and this arc. We connect these 2 points, 1, 2. Then we draw a horizontal, and we go back to that magic point. The angle is 15. We have a fully constrained sketch. Close. That sketch is inside the part. We use this tool, this subtractive pipe. We add an edge, this edge, and we have the first cut. Add edge, second cut, this edge, add edge. This is not so good solution, because we have a contour and normally we have to use sweep, not to add edge by edge, but this is FreeCAD. Okay, you see we have a similar sloped face like this. Very good. Now we have to add that missing entity about this vertical, and we also need to create this biconical feature by using this diameter of 51, these tapers of 5 degrees, and this dimension of 34. We turn back this face, we select it, and now without any other preparation we can apply pad. You see? Then we have to place here 4 divided by 2 and minus 15, the taper. Okay, you see now that nice final. Good. We select the plane XY. For the other problem we have, see inside project this arc to have a center, then a circle diameter of 51, close, extrude or pad, symmetrical on 34, and what is this? And the taper angle of minus 5. Okay, good. The other end, this one is not symmetrical about this vertical axis. It has 34 like this, but 9.5 is this face, and also diameter is 64.5 and tapers are different, 5 and 7. We'll use the tool revolve, new sketch in this plane, F7 is in Inventor, and view section is here. Why? Because we have this point. We draw a polyline starting from here, going here, and then horizontal outside, sloped here, and horizontal. Dimensions, this is 9.5 and the total dimension is 34. This angle is 5 degrees and the other is 7 degrees. This point is okay. Then diameter, half of that 64.5 divided by 2. Now we have a green sketch with fully constrained, close, revolve. We obtain directly this because Z-axis is by default. Okay. Here we place a hole, new sketch, project any circle, this one to have a center. We draw a simple circle, close hole of 41.8. Not with an end, but through the part. Okay. The other hole has some dimensions. You see here diameter of 55 with 2.15 this channel, this diameter of 52, radius 0.5, 47.5, and the distance of 25 and 30.5 of that faces. I want to show you this dimension, 41.8, this hole. We use this plane for a new sketch, section view, and some lines again. Polyline, starting from here, going down, then going somewhere here to the right, up. It is too far away, but I try to keep this lines, and I go somewhere here and back. Good. This line is fixed, yes, in the center. Now we project this line and this line. Why? Because we want to make coincident this line with this point, and also this line with this point. We also want to have this coincident with this. This dimension is 2.5, 2.15, not 5. Then this step is placed at 30.5, and this is 25 diameters. This is, I don't like to select two lines. I right click now and I select this and I have directly that dimension. You know this procedure. This is 52 divided by 2, and this point is at 55 divided by 2. Here is this is placed at 47.5 divided by 2. Fully constrained, close, and groove. The axis is by default OK. Here is a fillet. Radius 0.5. Fillet is here, not 1 millimeter but 0.5. Okay. Here is a chamfer 1 millimeter on 30 degrees, and then we see undimensioned fillets are radius 2. We have to apply such fillets in some places. We select this edge and we apply chamfer, not equal distance, not two distances, but distance and angle. 1 millimeter is okay, but here we have to apply 30 degrees. Okay. Other fillets are this one, fillet of radius 2. Okay. Other edges, other fillets, we keep pressed Control key to see this blue edges, then this and 2 millimeters. Okay, nice. What other? This, then control this, control this, control this, this and this, and on the other side control this, control this, control this, this, these are only placed, and fillet of radius to all of them. Okay, then this control this, control this, control this, fillet of 2. Okay, very good. And final object. That's all for today. Thanks for watching. Bye bye.